Dear learners, today we will see in this video a problem in which kinetics is involved. Kinetics means we know both the motion and the cause of motion are being considered. So in this problem, you can read the statement: two rough planes inclined at 45 degree and 60 degree to the horizontal are placed as shown in figure. Two blocks of weight 60 and 100 Newton are respectively placed on the faces of the arrangement and are connected by a string which is passing over a frictionless pulley. If the coefficient of friction between the planes and blocks is 0.35, find the resultant acceleration and the tension on the string. So you can see the arrangement. One plane is put like this at 60 degree with the horizontal and the other one at a 45 degree, and on the 60 degree incline a 100 Newton block is placed, and on the 45 degree incline a 60 Newton block is placed, and these two blocks are connected using a string. You can see the string which is passing over the pulley, and also it is given that the pulley is smooth, so we can assume it is having no weight as well as no friction. And another information that is given in the question is the coefficient of friction between the plane and the block. Then we have to find out the resulting acceleration of the system. So these two blocks will be moving simultaneously, and if one is moving in the downward direction, the other will move in the upward direction, or the other ways, or vice versa. That is, if this 100 Newton is moving downwards, this 60 Newton will be moving upwards. So the frictional coefficient between the block and the planes are given as 0.3. Okay, so as we need to find the acceleration as well as tension, we have to apply what we have to apply. We have to apply Newton's second law of motion. So what is Newton's second law of motion? Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the net force acting on the body, and we know the equation for Newton's second law, or mathematical expression of Newton's second law, as sigma F equal to ma, where sigma F is the resultant force and m is the mass and a is the acceleration, or the resulting acceleration due to the application of the net effect of all the forces acting on the body. So in this case there are two bodies moving simultaneously, or they are connected also. So this is a case of connected bodies also, and as these two bodies will be moving together with an acceleration of, say, a meter per second square. Why? Because the pulley is smooth, weightless, as well as the string is also having no weight. So both of these bodies will be moving with the same acceleration, but only difference is that if this is assumed to be moving downwards along the parallel to the plane in this direction, definitely this will move in the upward direction along the plane, but the magnitude of the acceleration will be same for both the bodies, because if this is moving, say, through 5 centimeters, the same 5 centimeters will be moved by the 60 Newton in the other direction. If this is moving in this direction, it will be moving in this direction. That is all. Okay, so with these two assumptions, and another thing is, one more thing is, we have to consider or assume a tension. So due to the action of these two blocks, its weight will be acting vertically downwards like this. It will be acting vertically down. This will be 100 Newton and this will be 60 Newton. And as this forces are acting at an angle to the planes, we have to resolve this into two components like this, along and perpendicular to the plane. That is parallel and perpendicular to the plane. We have to resolve these forces into, that is the weight, into two components. So this component will be 100 sine 60 and this will be 100 cos 60, and this component will be, this will be 100 sine 60 and this will be, sorry, this is 60 sine 45, 60 sine 45 as the angle is 45 degree, and this will be 60 cos 45. Okay, so this will be the components of the weights acting on these bodies, blocks, right? Now we have to consider the normal reaction, and as the frictional coefficient is given, that is the planes are given to be rough, we have to consider the frictional force also. So applying these conditions, we have to find out the acceleration and tension in the system. So the tension will be same on both the sides of the string. Why? Why is it so? Because the tension will be same due to the reason that this pulley is frictionless and weightless, and also the string is inextensible but weightless. Inextensible but weightless. Inextensible means it will not extend, but it is flexible. It is flexible and it is having no weight also. So with these points in mind, we can solve the problem. Okay, so I will draw the figure again here. So it is the 60-degree plane, the 45-degree plane, the horizontal. This is 60-degree, this is 45-degree, and the blocks are placed like this. This is 100 Newton, this is 60 Newton. Okay, so we assumed that the tension in the string T are same on both sides of the pulley. Tension in the string on both sides of the pulley are same. So, and let us assume that the 100 Newton is moving down with an acceleration of a meter per second square. We assume that this is moving at a meter per second square. So this will be moving up with a. Okay, so a in this direction for 100 Newton, because it is the heaviest thing, and block, and heavier block, and this is the smaller one. So this will be moving up and this will be moving down. And another thing is this plane is steeper, so this will have more tendency to move downwards. Okay, so we can say that the component of force under which this block is moving down is the one which is parallel to the plane. One which is parallel to the plane. Okay, and the one which is opposing will be the friction between this block and the plane, and here the friction between this block and the plane, and also the component of the force due to the weight of this block in this direction. These three will be opposing the force of this 100 Newton block. Okay, now to solve it, what we will do is we will be considering each block separately, and then you draw the free body diagram, form the equations, then we will get two equations in terms of T and A. Okay, T and A, then solve those two equations, you will get the required quantities. Okay, so let us see how to solve this. So first of all, we will assume that, we already assumed that the block 100 Newton block is moving down with an acceleration of A. So let us consider block A. Let this be block A and let this be block B. Okay, so if block A is moving down, we will draw the free body diagram like this. That is the 60-degree plane, the block, its weight acting vertically downwards. Okay, So the forces coming on the block are component of weights, normal reaction Rn, friction between the block A and the plane FA. So the component of the weight parallel to the plane will be 100 sine 60, and this one will be, I'll write it here, the component which is perpendicular to the plane is 100 cos 60. 100 cos 60. Okay. So these are the forces acting on the block which is having 100 Newton weight, which is at an angle of 60 degree with the horizontal. Okay. So now we will form the equation. Consider the forces parallel and perpendicular to the plane. We will form an equation. So first we will consider the forces perpendicular to the plane. Forces which are perpendicular to the plane. So which are the forces perpendicular to the plane? Rn and this 100 cos 60. Rn and 100 cos 60. Okay. So how we will apply the equation? So we know that there is no motion perpendicular to this plane. That is, in this direction the block is not moving. That means there we can apply equation of equilibrium. Equation of equilibrium in the perpendicular direction. That is, say, let us write Rn or consider Rn as positive. Rn as positive. Rn minus, so if Rn is considered as positive, definitely 100 cos 60 must be considered as negative. So minus, 100 sin 60 cos 60. 100 cos 60 must be considered as negative. So it is 100 cos 60 equal to 0. Equal to 0. It is not equal to ma because it is not moving in that direction. Okay. So the net force is Rn minus 100 cos 60, and due to that effect this body is not moving, isn't it? So the net force should be equal to 0. So Rn should be equal to 100 cos 60. 100 cos 60. So therefore Rn is equal to, that is equal to 50 Newton. 100 cos 60 equal to 50 Newton. Okay, so that is the normal reaction. Then, as we know the normal reaction, we can find out the frictional resistance between block A and the plane. That is Fa equal to mu into Rn. That is 0.35 into 50. So that will be equal to or we will calculate it later. We can directly substitute that value. Okay, now we will apply or we will consider the forces which is parallel to the plane. Forces parallel to the plane. Which are the forces parallel to the plane? That is 100 sin 60 and Fa. Okay, so 100 sin 60 and Fa are the forces which are parallel to the plane. And one more thing is there that I forgot. Actually, the tension in the string is also there. The tension in the string is also there. T. It is also there. Okay. So these are the forces which are parallel to the plane. Frictional resistance in the upward direction, tension in the upward direction parallel to the plane along the string upward direction, and 100 sin 60 parallel to the plane downward direction, under the effect of which the block is moving down the plane, or assumed to be moving down the plane with an acceleration of A. Okay, so parallel to the plane, these are the forces acting on the block A, and we will write the equation as, we will consider 100 sin 60 as positive because it is moving in the direction of motion of the block. So it will be 100 sine 60 minus t minus Fa equal to, what will be the net force? Sigma F equal to, should be equal to Ma. Ma into A. Ma into A. Because here we cannot consider it as in equilibrium. It is moving under the action of this force. So here the forces must be considered as according to the Newton's second law of motion. Okay, so it is Ma into A. Therefore, it will be 100 sine 60 minus t minus Fa equal to Ma is 100 by 9.81 into A. Okay, so that will be the equation. When you substitute and simplify these values, terms, you will get so when we substitute the values, we will get 100 sine 60 equal to 86.6. It's approximately equal to 86.6. 86.6 minus t minus 0.35 into 50. Not clear. So it is 100 sine 60 will be 86.6 minus t minus 0.35 into 5 equal to 100 by 9.81 into A will be 10.19 A. 10.19 A. So this is equation number 1. Okay. So this equation is from equation number, that is considering the block with 100 Newton weight, or block A. Now let us consider block B. Block B. How block B will be? It will be on the other incline at 45 degrees. Okay. So this will be the block, and its weight will be acting vertically downwards like this, and its components will be like parallel to the plane. This will be the component, perpendicular to the plane. This will be the component. The friction will be acting downwards. Why? Because this block will be moving upwards with an acceleration of A. Okay, this block will be moving with an acceleration of A in the upward direction. Say A in the upward direction. So friction will be in this direction. Let it be FB. FB is the friction, and this component will be 60 sine 45, and this component will be 60 cos 45. Okay. Now one more force we need to consider is the tension in the string, which is T. Tension in the string, which is T, in the upward direction parallel to the plane. So these are the forces acting on the block B, which is having 60 Newton weight, isn't it? Then Rn, of course, we will have to consider. That is, let it be RB. Okay, at the contact surface of block B with the plane at 45 degrees RB, the normal reaction. Okay, so with these points we can consider the block B. Let us consider block B. First we will consider the block which is perpendicular to the plane. What are the forces perpendicular to the plane? Normal reaction RB and 60 cos 45. 60 cos 45. So RB minus 60 cos 45 equal to 0. Why it is 0? Because there is no motion perpendicular to the plane. So it is, these two forces are equal. These two forces must be equal. That means RB equal to 60 cos 45. that is RB is 42.43 Newton. It is 42.43 Newton. Okay. Then if RB is 42.43, that gives FB equal to 0.35 into 42.43. So FB is equal to, that gives FB equal to 0.35 into 42.43. Okay. Then when we consider the forces parallel to the plane, considering the forces parallel to the plane, if this body is moving upwards, if we consider the forces parallel to the direction of motion, T will be positive, this will be minus, and FB will also be minus. So parallel to the plane, the forces acting, and the net force will be T minus 60 sine 45 minus 0.35 into 42.43 equal to MB, because it is moving in that direction, so we have to apply Newton's second law of motion. Sigma F is equal to MA, so it is equal to MA. Here MA is M is 60 divided by 9.81 into acceleration is same. So this is the equation which will be formed by considering the forces parallel to the plane and applying Newton's second law of motion. Okay, so when you simplify this, you will get, what you will get? You will get T minus 57.28 equal to 6.11a. Let this be equation number 2. So now we have two equations. Equation 1 in T and A. Two unknowns are there, T and A. Here we have equation number 2, which is having two unknowns, T and A, no other unknowns. So we have two equations and two unknowns. When we solve it, you will get the values of the acceleration and tension in the string, acceleration of the blocks and tension in the string. Now how to solve it? Consider these two equations, that is 86.6 minus T equal minus 0.35 into 5 is equal to 10.19a, and if you want this is 50, 0.35 into 50 equal to 10.19 into a. So 86.6 minus T minus 0.35 into 50 equal to 10.19a, and we have this equation T minus 57.28 equal to 6.11a. When we solve these two equations, we will get T equal to 61.7 Newton and A equal to 0.725 meter per second square as the answers. So these are the answers for the problem. The tension in the string T will be equal to 61.7 Newton and acceleration is equal to 0.725 meter per second square. Okay, so here we considered the two blocks separately. We formed the equations for each case, then solved the two simultaneously to obtain the results T and acceleration A. Right?